next problem number 4, it says f of x is, you're given the first and the function, the first and second derivative, so find the following. Well, the domain, no denominator, no radical, so the domain is all real numbers. X-intercepts. X-intercepts is going to be where y equals 0. So that's going to be 0 squared minus 4. Whoops, I'm sorry, wrong thing. X squared minus 4 cubed equals 0. X squared minus 4 equals 0, so x is going to be plus or minus 2. So x-intercepts are plus or minus 2, 0, so you have 2 of them. And then the y-intercept, that's where x equals 0. Or you're going to have 0 squared minus 4 cubed, which is minus 4 cubed, or negative 64. So it's 0, negative 64. So now I have 2 coordinate points on my graph. The next thing's going to come off of the derivatives, max, min, inflection points, increasing, decreasing. So I'm going to divide my paper now into 2 pieces, so I can work with the derivative separately. So f prime of x equals 6x times x squared minus 4 squared. Set that equal to 0. X is 0, and there's a change there because this is multiplicity 1. X is plus or minus 2, but because it's squared, this is multiplicity 2, so there's no change. So I have 0, minus 2, and 2. Change, no change, no change. So I've got a max or a min at 0, so I'm going to pull a test point, x equal 1. And if x equals 1, well, I'm looking at a squared. This is always positive, so 6 times 1 times 1 squared minus 4 squared. That's going to be positive. Change, negative. No change, negative. No change, positive. So negative followed by positive. I have a min at 0, but no max. So I can now answer the question up here, what is x values of any local maxima or minima? I don't have a maximum, but I've got a minimum at x equals 0. We now go after the second derivative, which is 6 times x squared minus 4 times 5x squared minus 4 equals 0. They're all going to be multiplicity 1 coming out of here. This tells me that x equals plus or minus 2, and x equals plus or minus the square root of 4/5, all multiplicity 1. So that says I have 4 inflection points. So I can already answer that question because they're all multiplicity 1. So plus or minus 2, plus or minus the square root of 4/5, or 5/4. Yeah, no, 4/5. So now we go to find concavity. So I'm going to, this is going to be about 0.8 or 0.9. So I'm going to have negative 2, change, square root of negative 4/5, change, 2, change, and let's not forget the other guy, square root of 4/5, change. So I just need a test point. 0 is available to me. So I'd have 6 times 0 squared minus 4 times 5 times 0 minus 4. This is going to be 6 times a negative number. That's going to be negative 24 times negative 4, that means positive. So concave up, concave down, concave up, concave down, concave up. So I'm going to be reading all of this off. Concavity, let's do that first. It's going to be concave up from minus infinity to negative 2. Then it moves to concave down from negative 2 to the square root, negative square root of 4/5. Then changes the concave up between negative square root of 4/5, square root of 4/5. Then changes again the concave down to the square root of 4/5 to 2. Then concave up again from 2 to infinity. Now, let's go for increasing, decreasing. Decreasing from minus infinity to 0. And increasing from 0 to infinity. That was easy enough.